Everyone, if you're new to the channel, you can subscribe to the channel for future updates. And guys, please visit my website, guys. You can check the link in the description below. And of course, I have launched the new Instagram account and make sure you follow for more future updates. Enjoy the solutions. Hello everyone, welcome to this Monbukagakusho Mathematics A 2016 Part 2. And we are going to continue the series of Math A 2016. And yeah, this is part 2. Consider a parabola y equals x squared. So it is the easiest graph to draw. You just only make the graph this way. Remember that the graph parabola y equals x squared is tangent to the x-axis. And number 1, the line that goes through the point 0.3/2 and is orthogonal to a tangent line to the part of the parabola y equals x squared with x greater than 0 is what? So basically it's saying that in the part of x greater than 0, there's a tangent line, for example, in this point to the graph, right? Then there's a line that goes through 0.3/2 and is orthogonal to the tangent line, which means the line here is perpendicular. Okay, so the first question asks what is the equation of this perpendicular line. The first thing that we need to do is we have to find the gradient of this tangent line, right? The way to do it is we differentiate the function, so that it is 2x, but we didn't know the x coordinate of the intersection, so we just assume it as a, right? As a. So to find the gradient, we have to put the x coordinate to here. So the gradient m is 2a, right? And let's say the y coordinate of a is b, right? Let's say the point here is a and b. Okay, so we have to point a and b and the gradient to a for the tangent line. So the equation of the line, this is the formula, where y1 is the y coordinate, b, m is the gradient, and x1 is the x coordinate. Okay, so we basically get this equation. And now we could actually form the perpendicular line. Remember that the gradient of the orthogonal or the perpendicular line times the gradient of a line that is tangent to something equals to -1. So we can find the m of the orthogonal because the gradient of the line is 2a. So the gradient of the orthogonal is -1/2a. Let's say that gradient 2. Okay, and also this line goes through 0.3/2. So we could actually form the equation y minus y1 is 3/2 here equals -1/2a x minus 0. Okay, so y minus 2 minus 2/ax, so y equals -2ax plus 3/2. Now you could see that this x is the variable for the x coordinate, and we have that the x coordinate is a, so we could actually substitute that -1/2a times a plus 3/2, so that is 1. So we got that the y coordinate is 1, so b is 1. And remember that in y equals x squared, if y is 1, so the x is also 1. Now we got the point of this intersection is 1.1. And now the next step is just, we could actually find the equation of the line. First thing is that we got the point 0.3/2 and point 1.1. And the formula of equation of the line for two coordinates is this one, y minus y1, y2 minus y1, x minus x1 over x2 minus x1. And I assume that this is the 1 and this is 2. So y minus y1 and then y2 minus y1, x minus x1, x2 minus x1, right? So y minus 3 over 2 equals minus half x, so that y equals minus half x plus 3 over 2. Okay, so that is the answer for number 1. The box 2, 1 is minus 1 over 2. And now it says, and the x coordinate of the intersection of the above two lines is 1. X coordinate of the intersection is 1. Right? And now for number 2, it says that with respect to the intersection, it holds that the integral, because the answer of the box 2 is 1, so the integral with a limit of 0 to 1 x squared is, we just calculate this integral, become 1/3 x cubed with a limit of 1 to 0, so that is 1/3 times 1 cube minus 0, so that is 1 over 3. So that is the answer for 2, 3. And they said we assume this area as S1, right? So number 3 now. Letting S2 be the value of the region with the line, the parabola, and the line x equals 0 implies S2 is what? So S2, they said, is actually the area between the line, which we had got just now, passing 3 over 2, right? And then intersecting the parabola x squared. This is 1. We have got that. And between also the line x equals 0. So this is 0. X equals 0 is actually this one, the line, the y-axis. So this is the area that we need to calculate. This is the S2. They ask S2 in box 2, 4, right? So we could actually calculate this, because this is fx, I mean the line is above the parabola, so we make that S2 is the value of the integral from 0 to 1 of this is minus half x plus 3, 2, right, and minus x squared, right? And we actually could calculate this. This is minus half times half x squared plus 3 over 2x minus 1/3 x cubed, put there inside, so that is minus 1 over 4 plus 3 over 2 minus 1 over 3, and 0, everything would be 0, so we only calculate this, so that is 3 over 2 minus 7 over 12, right? And we got the answer of 11 over 12. Okay, so this is the area of S2. And now the final question of part 2, number 4. So the ratio of S2 by S1, remember that S2 is 11 over 12 and S1 is 1 over 3. So we got that is equal to 11 over 4. So that is, everyone, the answer for Mathematics A, part 2. And yeah, hope you understand that, and stay tuned for part 3.